Hello everyone. Welcome to our video titled Sustaining the Lifeblood, the water cycle in the Philippines. Today, we delve into the intricate workings of the water cycle, the human impact on it, and the roles of invasive species and epigenetics. We'll guide you through the first part of our discussion, the biochemical cycle of water and its steady state in our environment. The water cycle or hydrological cycle is a continuous process by which water moves through the earth and its atmosphere. The cycle is crucial for maintaining the balance of our ecosystems, ensuring that the water is available for all living organisms. In the Philippines, with its diverse and rich aquatic environments, this cycle is vital in sustaining life. The water cycle operates steadily, where the water evaporating from the surface equals the amount of water precipitating back. This balance is essential for maintaining our ecological reservoirs like rivers, lakes, and aquifers. However, this balance can be disrupted, leading to significant environmental changes. This brings up to Le Chatelier's principle, which states that any change in the equilibrium of a system will cause the system to adjust to counteract that change. In context of our water cycle, any external stress such as pollution or deforestation can significantly alter the balance of our water systems.
Human activities have significantly impacted the water cycle in the Philippines. Industrialization, urbanization, and deforestation are some of the primary contributors to this disruption. Let's look at each of these factors in detail. Firstly, industrial activities release pollutants into our water bodies. Chemicals, heavy metals, and other contaminants degrade water quality and disrupt aquatic ecosystems. This pollution affects not only just the flora and fauna, but also human communities relying on these water sources for drinking and agriculture. Secondly, deforestation is a significant issue. Forests play a critical role in regulating the water cycle by maintaining the water balance and preventing soil erosion. When forests are cleared, the natural filtration system is lost, increasing runoff and sedimentation in water bodies. This can cause flooding and reduce the availability of clean water. Lastly, urbanization increases water demand and alters natural water flow patterns. Cities require vast amounts of water for domestic and industrial use, often leading to over-extraction of groundwater and depletion of aquifers. Additionally, constructing impervious surfaces like roads and buildings reduces natural water infiltration into the soil, increasing the risk of floods. These anthropogenic stresses on the water cycle can be understood through the Le Chatelier's principle. The ecosystem tries to counterbalance the changes imposed by human activities, but this often leads to unintended consequences and further environmental degradation.
Invasive species are non-native organisms that cause harm to the environment, economy, or human health. In the Philippines, invasive species like the golden apple snail and tilapia have significantly altered aquatic ecosystems. These species often outcompete native species for resources, leading to declining biodiversity. For example, the golden apple snail, introduced for aquaculture, has become a significant pest in rice fields, causing substantial crop losses. Similarly, tilapia, while beneficial for fish farming, can disrupt local fish populations and ecosystems when they escape into natural water bodies. The presence of invasive species can also stress the water cycle, as these organisms may alter water quality and availability. For instance, some invasive plants increase water consumption, decrease water levels in rivers and lakes. Now let's talk about epigenetics. Epigenetics refers to the changes in gene expressions that do not involve alteration in the DNA sequence. Environmental factors, including stressors like pollution and invasive species, can trigger these changes, affecting the health and behavior of organisms. In the context of water ecosystems, epigenetic changes can influence how species adapt to environmental stressors. For instance, polluted exposures can lead to epigenetic modifications that affect the aquatic ecosystem's reproduction, growth, and survival rates. These changes can have long-term implications for biodiversity and ecosystem stability.
Thank you for joining us today. We've explored the biochemical cycle of water, the anthropogenic impacts, and the roles of invasive species and epigenetics in our ecosystems. Understanding these factors is crucial for sustaining the lifeblood of our planet, water.
Let's cooperate to protect and preserve our water resources, ensure a sustainable future for all.
Remember, every small action counts, from reducing pollution to supporting conservation efforts. We all have a role.
Thank you for watching.
Thank you for watching.
Thank you for watching.